This video we're going to take a look at how to create our G-code in Toolpaths within Cabinet Parts Pro's Partnester version 3. We are working with just a few parts across 2 sheets, and we're going to just focus on how to create the G-code for this. So starting at the top of the right side, we have our list of features that are needing to be toolpathed. Unlike most CAD/CAM programs, we do not have to come in and select the objects of what we want to create the code for. Meaning I don't have to come over here and select each circle or each line that I want to create for. What we are doing, we're selecting them by the list of features, which is the DXF layers, if you're familiar with and use layers. So we'll just start at the top and work our way down. We have, the first 3 toolpaths here are drilling and drill related. So we're going to start again at the top and work our way down through that list. The tool name really doesn't matter. I just like to keep that somewhat straight to the tool diameter. The pass depth, we'll see more on that later, but that is how deep we are going to allow the cutter to make in a single pass. The step over is for pocketing. If we are going to clear out and pocket in a larger rectangle or a larger shape, this is the distance that it steps over before making its next pass. The tool diameter, well, that's for your tool changer. Depending on what tool number you have that particular bit into. The ramp distance is going to allow it to start at the top and ramp down into the material rather than going straight down and then moving along. We'll come back and see that in a little more depth when we come to the final cut layer. RPM, feed rate, and plunge rate is just the same with any other CAD/CAM program that you would have, or what you want those settings to be best for your machine. The add to depth, one setting you may see that's kind of missing from everything here is how deep are we going to cut these objects. Well, the depth is all based on the drawing of our objects. So the hinge hole depth that we have here, that is coming from Cabinet Parts Pro, and my setting I believe is 1/2 inch deep. So that's how deep it is going to cut or drill. If I wanted to cut a little bit deeper, I could add to this number. If I didn't want it to cut as deep, I could subtract from the depth. We'll see that also in the final cut parameters. The V-bit angle, that is if we are creating MDF doors and we want to use a V-bit to create sharp inside corners. This would be where you specify the angle of that V-bit. Now for the tooling offsets, for these 2 single holes across the for the drawer holes, then choose the option for a drill. The direction does not matter for this case, and select a post-processor. Scroll down and click Save as Template. Now that is saved, and we won't have to make any more modifications to the drawer toolpath until we make a change or want to make a change to that toolpathing. Also notice that I've selected off of the drawer holes down into the hinge holes. It does say that this layer is not set up. By coming back up to and selecting the drawer layers, we see that that is no longer there, meaning that that layer is now has a template that is associated with that name. For the hinge holes, going to do exactly almost the same thing. This time these holes are set to be 32 millimeters apart, so I'm going to set the option for a drill bank. That is going to allow us to use a drill bank if you have one, and drill both of those holes at the same time. Going to come down and select a post-processor and back up to the top and select the next item in that list. It's going to be the same, so I'm just going to come straight down and click Save Toolpaths. going to work on the backside layer now, and we don't see any of that selecting. So nothing appears to be selected. Like when we select the shelf holes, we see they become selected, or the cut that becomes selected. But this one, nothing is being selected. Well, the reason for that is that feature is not on this sheet at all. It is on sheet number 2. And we don't have to be viewing the sheet that we're creating the toolpaths for. This is just kind of a global setting for all layers across all sheets. So for that, let's use a 3/8 cutter. The pass depth, that is, again, how deep we're going to allow it to cut in a single pass. So really, this number could be 6. It doesn't matter. It's still going to be limited by the geometry of our cabinet part. The offset I'm going to choose to do on the inside, and when we select the option for inside, we have a pocketing checkbox. I do not have to have that checked because the width of that dado, that 3/8 cutter, is going to allow it to all cut in a single pass without having to step in. Setting the direction of cut to be a conventional, that is a left to right cut. When cutting on the outside, it's kind of a left to right on the outside cut, as a traditional router would be, and what will give you the best cut most of the time cutting sheet goods and composite material. Saving that as a template, again coming back to the top, almost done. I'm going to set this to be exactly the same thing. And then the final one is the cutting tool path. I'm going to set the option tool offsets to the outside. Everything else I'm going to remain the same, other than I do see I forgot to do something here. So we have a tool number. So far, all of these tool numbers, everything was using the same tool number. And notice when you select in any one of these features, you see the options change. So we can see that they have been saved. All of the drilling tool paths are using tool number 1, other than we have the 2 hinge holes and the shelf holes that are using the drill bank. So there isn't a tool number associated necessarily with that one, but the last 3 are still using tool number 1. So I'm going to change that to use tool number 2. Now, once we have all of our toolpath templates saved, there isn't anything more that we have to do even the next time we open it. So we could close the PartNester and re-nest those parts, and all of those toolpaths are still going to be set up as we see when clicking through these. So the next step to do is come down and click the button to save toolpaths, give it a name. It is going to give you 1 G-code file for each nested sheet. We can now see that we have a dotted line showing the center path of the cutter, and going to the folder that has created those files, we have 2 cutting files there, along with an informational sheet about those 2 sheets, or what is being cut on those sheets. So now we have and are going to take a look at what other options we have within here are. So one we're going to take a look at is this pass depth. So I'm going to use this orbit button. Clicking that allows us to rotate this around, and I'm just going to zoom into a section where we could see the initial plunge point into the material for this particular cabinet part. So we see this line right there. That is the material coming in all the way to depth and then going around. We actually need to cut this just a little bit deeper because right now that is down at 3/4 of an inch. So it probably would not cut, with a vacuum and everything else, inconsistencies possibly in the table. We want to set that to be cutting a little bit deeper. So I'm going to enter in 0.02, just add 20 thousandths to the total depth, and clicking Save Toolpaths and save once more. I'm going to overwrite the file that we have there. That little bit of a difference, you may have noticed that it did shift and we saw a little bit of movement in that line, but it just went down that 20 thousandths of an inch. Now if we want to cut in multiple passes, we could do that by changing the pass depth, or the depth per pass. Right now it's 6. That means that we can cut up to 6 inches in a single pass if we had a bit long enough to do so. But if I want to cut in 3 passes, or 3/4 of an inch in 3 passes, I'm going to change this pass depth to be 1/4 of an inch, and making sure that you have the correct layer selected, or the operation selected. Saving that and clicking Save Toolpaths once more. We will now see that we have 3 separate passes for that final perimeter cut. I'm going to set that back to allow it to cut in a single pass. And again, anything greater than the material thickness will allow us to cut in a single pass. So setting that to cut, and just set that greater than the material thickness, and click Save Toolpaths. So that brings us back into making a single pass. The other option that I want to kind of explore is the ramp into the material. Currently it's going straight down and around, straight down and around. Now that could cause some extra heat buildup in the cut, and shorten the lifespan of the cutter you're using. So we want to ramp in. So I'm going to set the ramp distance. Well, let's go with a ramp distance of 3. I think that's a little much than I would normally do, but just so we could see what's going on here. We now have a diagonal line, which is our plunge line, starting at the top of the material, ramping into the cut as it goes around and finishes out. So the next thing I'm going to take a look at is, and it would step in and ramp in like that per pass. So again, let's change that to a depth per pass back to an 0.25. I'm going to shorten that ramp distance a little bit. I think that's a little much. So I'm going to say 1 inch, and again, making sure that we have the cut layer selected. And it actually still looks like it is going over that total length of 3 inches. But what it is doing, it is going a distance of 1 inch to get down to the first pass. The second pass is also going down another 1/4 of an inch. So it's moving from that level down. So overall, our total length of this ramp is still that 3 inches, but we're doing it over the step down of 3 separate passes. So changing that back to a single pass. Again, anything greater than the material thickness is good there. Saving that as a template and calculate, or clicking Save Toolpaths. We will now see that it's going to make a single pass, and that ramp angle changes based on that being a distance of 1 inch from the starting point over the length of that cut. Another option we could take a look at is onion skinning. So onion skinning is a way that we could cut almost all the way through for the first pass and then come back and remove that last pass. So the reason why you would want to onion skin is if you are challenged with hold down, if you're afraid these parts are going to move or don't have a great vacuum for hold down, you could use onion skin. So the first pass would take the majority of the material out and have the most force, leaving maybe 30 thousandths material left, and then the final pass would come back and remove that. So we're going to take a look at our settings, tools, and then settings. We have an onion skin setting here that is set to be 0.03. This is the amount of material that is going to be left after cutting its first pass, and then it will come back and cut all the parts again at full depth. So we will explore that at this time. So going to now click the option for cut layer, set for an onion skin, come down and click Save Toolpaths. We now see that we have two lines that are making up that cut. One is the initial cut, the top one there, taking up the majority of the material. Then the next pass that we see here, that is the final cut that is removing that onion skin. So that onion skin is really a nice aid for when cutting materials that or cutting on a table that you may not have great hold down. Now I do have the orbit happening here, so to get back to top view, I'm going to click Zoom All. That zooms us back in, and just to point out that we've only been viewing the one sheet, but all of the sheets or multiple sheets have been updated at the same time. So again, with everything, all the toolpaths templates set up and ready to go, we could always close the nesting and modify, if we wanted 2 cabinets, double them up, and we're going to end up with more sheets than just those 2 sheets. There isn't anything else that we will have to do in setting our toolpaths up other than coming over to the bottom, clicking Save Toolpaths, giving it a name, and it is saving all the toolpaths for all the sheets. So we have 1, 2, 3 sheets, and we could see the toolpaths have been created for each of the sheets. So hopefully this better explains and is useful in how to create toolpaths from within Cabinet Parts Pro's PartNester version 3. If you have any questions, send us an email and we will do our best to answer them.